So again, the first step in using the Strand7 software, we create a new file from this tab here. Okay, and the first page we will face is the units when we open a new project. So we will try to keep the units as meter length, MBA, kilogram, kilonewton, joule, Celsius, and okay. So this is our first step. What is the second step? You can see the windows. Okay, I will do it again. Okay, can you see it now? Okay, thank you, Dr. Zeng. Okay, so now again, we will open a new file. This is a new file. So firstly, we assign the unit. So we have meter in length, MBA in stress. The force, we will make it kilonewton. This is the common units we use. The mass, we will keep it kilogram. The energy, joule. The temperature, we can make it Celsius. And then, okay. So now we have assigned the units. The second step is to start drawing our truss. So as you can see, our truss, or our frame, sorry, we can start using drawing using the coordinates. Okay, so if we go back, 1 second. So this is our truss or our frame. So the first node, so this is our truss. Okay, so this is our problem. This is the given frame we want to model. So what we will do is just assign the coordinates to know how to start the drawing on the software. So I will assume this is our origin, and this will be our axis, y-axis, and this is our x-axis. So if this 0 and 0, the total distance here is 6 meter. Each spacing is 2 meter. So this is the whole 6 meter. And the height here is 2 meter. So now, what is the coordinates? If this 0 and 0, so this will be 2 and 0, this will be 4 and 0, this will be 6 and 0, and the upper side will be 2 and 2, because 2 in x, 2 in y, and this one will be 4 in x and 2 in y. So this is the coordinates we have, and now we return back to the software to start drawing. So now we will start drawing using create. So create, we start with nodes because we have nodes. The first node is 0 and 0, so we can apply. Second node is 2 in x and 0, apply. Third node will be 4 in x and 0 in y, apply. The fourth node is 6 in x and 0 in y, apply. The fifth node is 2 in x, 2 in y, apply. The sixth node is 4 in x, 2 in y, and apply. So now we have created all the 6 nodes. We need to draw the truss or the frame, sorry. And now I will start drawing the members. So firstly, I draw the nodes. Secondly, I will draw or create the members. So from create again, if you can see create here on the top. So create, we have elements. What element we are using? We have beam 2, beam 3, try 3, quad 4, try 6, and so on. This is a beam element, so we can use beam 2. This is the simplest element, simplest beam element. And we haven't defined any property yet, so we can keep it as 1. So I will now start drawing. So from node, the node, when we click it and then connect to the other node, so the software will draw a member between them. Secondly, from node 2 to 3, second member, from 3 to 4, and then we can use this one here. So just connecting the members together, and we will finish drawing the frame. Okay, so this is the members we have, and we have a member here from here to here. So now we finish drawing the members. So these members have been drawing using the node's coordinates. Okay. The second step is to assign the supports. So how to assign the supports? If we go on the top here, we have attributes. Attributes is responsible for the properties of the, like how to assign the properties of the nodes, beams, and plates, or all the members. So I will click node because the support is a node restraint. So under node and then restraint. So we can click restraint. So this will help us to assign the supports. What is the supports we have? We have here on the left side. If I left click on it from the mouse left click. So now I picked the node or select the node. So we can select types of support, free or fixed or X symmetry or Y symmetry or hinge and so on. So what we will do is fix. Fix mean all the translations are 0, so that's why all selected. All the rotation are 0, that's why all selected. So now we can, is it fixed or hinge? So this is if it's fixed, but we are, so we have to make it hinge. What is the hinge means? So we can make translation in X and Y are restricted, and for rotation, the rotation is allowed about Z. So I will keep the rotation, and so I prevent all the translations and only keep the rotation in Z. This means we apply a hinge here. Okay. Here on the right side we have ruler. So I will select the point. So the ruler allow the translation in X direction and also allow the rotation about Z. So apply. So now at the right side or the right point, we have a ruler support. Okay. So we have hinge support to the left and right support to the right. Okay. So now we have finished the support assignment. What is next? The next is to define the properties of the material. sorry, the properties of the members and the cross section of the member. If you can see here, if you go back to the, it is given here that the members are UB 150 ET. So if we go back to our software, so we need to define the property similar to what is given in our example. So if we go up here to the property tab, this tab to define the material or the member property. So under property, this is a beam property. So now how many members we have? We have only one. So if you want to make a name for it, you can edit property name and we can make it as frame element or whatever the name is. But from this tab, you see this like hand holding a pen. We can change the name. Okay. So what is the name? What is the material property here? The material, we can click the materials. This is the materials in the software library. We can use, because this is steel, so we can use the structure steel. So steel and okay. So now we define the material property as steel. Now if we want to like use a section as it is given, so where to find the sections? So now we are structure. If we go to tables, section here, if you want to enter the properties manually, okay. But now we can go to geometry to select a section. Here you can edit and draw the section yourself or whatever the, like if we click edit here, so you can select from some given default cross section. But here we have a library as well that is like including all the available cross sections in the markets. So if we go here, we can select the section, any section we need, like here. So we have some Chinese cross section, some Australian cross section, European, and so on. So if we go here, we can use whatever you want. Okay, so now if we go to the BHB universal beam, as here, you can see that we have BHB universal beam 150 UB18. This is the one given to us in the example. So I will click this one from the library and then click OK. So now, after it loads, now the material or the section 1 we use to draw the frame elements will be this I-beam or this UB section. Okay. The only thing we need to consider here is we are doing a frame in this part of the example. So that's why the type of the member is beam. Because in the second trial of this example, we will change to a truss. This one thing you need to consider or keep in mind when we are doing a frame or make the software will consider the connection between the members as rigid connection. So to consider it as rigid connection, you have to select beam here. If you select other types, it will not work as a frame. So you need to select beam. Now, okay, or close. So now the members are it UB 150 ET. Okay. If we want to make sure that it is already selected, if we go to view under entity display, entity means the member. So if we go to the second tab, beam display, so you can see okay. If we can display mode, if it is line, so it will show a line. If it is solid or section, it will show the section we have already selected. So because we have selected UB, this is the shape of the members. Okay. Now, what is the next step after we like define the materials and draw the geometry? The next step is to define the loads. How many load cases we have? 3 load cases, two single load cases, and only one load combination. If you can see here, this is the load cases list. So we can have one load case and second load case. So from global here, this is under global, we have load and freedom cases. So how many load cases we have at the moment? Only one load case. So we need to have two load cases. Make sure that you are under primary load cases. So we can make a new case. So load case 1 will be for the vertical load, load case 2 for the horizontal load case. So now we have two load cases defined already. So under one load case 1, I will make the add the load. So under attributes, load 1, as you can see in the example here. So load 1, where is load 1? Load 1 in the middle or the center of this member. So this is load 1. So now I will go back to the software and we have to select the member. So I will return the view back to line to make it easier. And now under attributes, beams, because the load will be applied on a beam element. So under beam, we go to a point load. So it is a point load and it is a force global. So I will select this. Now, as you can see, this is the load. Firstly, I need to select the member. So I already selected the member. Where is the load and what is the direction of the load? The load is in Y direction, so it will be in Y direction, and it is go downward, so it will be negative 10. And the units here is clear as kilonewton, so the units are okay. But where is A? Where is, as you can see, A is the percentage of the location to the total length. So where is A? This load will be in the middle of the member, so A will be 0.5. And then apply. So as you can see, the load is now in the middle. But what is the value of the load? To show the value of the load, we go to view and under attribute display. This is for node, this is for beam element. So we have point force on a member. So we need to show, this is to show attribute, the arrow, but this to show the value. So if we click or tick show the value, now the value is shown on the member. Okay. So this is our second step to apply the first load case. The next step is to apply second load case. Don't forget to select the second load case from the load list. Then similarly, we will go to attributes. But here, this force, if you can see here, this force is applied at a node, not on a member. So if we go back to the software, so we will have to select this node, firstly attributes, but it is under node force. So we will select the node and then this force in X or Y direction. This force not in Y direction, it is in X direction. It is in the positive direction of X, so 30 kilonewton and apply. So now if we look at the force, here the force is clear on the screen, but just as a view. So if we make the view again, attribute display, but here under notes, force, show value, and then apply. So now the force is here. So we have two load cases. If we want to change between them, load case 1 and load case 2. So now we almost finish, but we need to uh, do the load combination. How to do the load combination? Under results, you will find that we have a tab for linear load case combination. So I will click this tab. So now you can see a blank page. To add a new, so to add a new load combination, here under add, to the right, add, and we load combination case. If you want to give it a name, let's say uh, comb 1 or combination 1, because we have only one combination. So how much is the load factor for load combination 1? We are just like adding them together, so the load factor will be 1 and 1. So 1 multiplied by the force in case 1, 1 multiplied by the force in load case 2, and then okay. So now we have added the load combination and the load cases. What is next? The final step is to run the model or solve. So under solver, you will find solver here. We have different type of analysis, but here we are just doing a linear static analysis. So the first one, linear static analysis, the basic analysis. So I will give it as example 1 and save. So now we have this screen. We don't need to change anything in this screen now. So what I will do is solve. As you can see, the solve is okay. No problem. Number of warning 0, number of errors 0. So the solution is correct. So now everything is done, and we can now under result, to show the result, we have to click open results file. This is the result file I have done. Now open, and the software asked me, the model has one load case combination. Do you want to generate them? Sure, yes. So now we have opened the result file. To show the results file, you have this list here on the right, or under results, you have displacement scale and result settings. Under displacement scale, we can assign what is the scale of deformation we need to show. Let's say 20% and see what happens, or make it 10%. Okay. So now, what is this? This is the displacement or the deformation shape of the frame under load case 1. And this is under load case 2. And this is under the load combination. Okay. Firstly, if we want to show 3 of them together from view, we can do multi-view. How many X views and Y views? If we want to make it like 3 columns, so we can divide the screen to 3 because we have 3 load cases. As you can see here, we can show here load case 1, here load case 2, and here is a combination. Okay. Okay. So now we can show the 3 cases together and compare with between them. So now we are showing what we are showing, the deformation. If we want to show a different criteria, we can show a diagram of, we are looking for plane 2, so we can show the shear force or bending moment. Let's see the bending moment. So this is the bending moment here, but it is not looking good on the deformed shape. So what I will do is remove the deformed shape. So this is the moment here and same here. Okay, and also same here. Okay, so this is how to model this frame and show the deformed shape and bending moment. If we want to show the shear, so from result settings, you can have under diagram forces. So you can show the shear force instead of the moment. So this is the shear force. Here also this is the shear force. And on the combination here is the shear force. Okay. Do you have any problem? Any question for this one? So this is the first example. Example number 1. But we need to also have another case. This is one we consider the members as a frame, and when we define the members, we select as beam. So the second will be same thing, but we just consider it as truss instead of a frame. Okay, the difference will be just a quick one here. What is the difference between if we consider it as a frame or as a truss? As a frame, if this our frame, so this connection considered as the software considers them as rigid connection. So this member work as a frame, and in the software we have to use the member type as beam. In truss, it is same drawing or same layout, but the connection here between the members is not rigid. It is a pin joint. So when to consider it as truss, you have to model it on the software as a truss. So this in strand 7 and here in strand 7. So this is the difference between the modeling in both cases. Okay. So now if we return back to our software, okay, so what I will do is just quickly open a new one. The forces are the units, sorry, is MBA, kilonewton, Celsius, and so on. So again, we'll create same things. So what is the dimension or what is the coordinates of your node 1 is 0. Node 2 is 2 and 0. Node 3, 4 and 0. Node, sorry, node 3, 4 and 0. Node 4 is 6 and 0. Node 5, 2 and 2. Node 6 is 4 and 2. So now we finish drawing the nodes and then create element beam again. So what we will do is just connecting the members again. So member 1, member 2, member 3, member 4, member 5, member 6, number 7, 8, 9, so on. So next is attributes restraint. So under here, this node is hinge, so we prevent X, apply. Here is roller, so select the node and allow for X, so apply. So one is hinge, one is roller. The next step is probability beam element. Here is the difference. Again, we will rename this to make it rename from here. Make it truss because this is truss element. The material of this truss element is also steel, so steel. But here we select beam or truss. The software will not consider the connection as been joined until you select this type of member as a truss. So this is the difference. Here we need also to select the geometry. What is the geometry from the library? We have BHB Universal Beam 150 18. So this is the member. And now close. So the member is to make sure it is already assigned infinity display. So line solid. So now the members are assigned. Everything is okay. The next step is to how many load cases we have. 2 load cases. So under global load, create another load case. So load case 2 for the horizontal load. And under load case 1, we have to attribute beam point load force global. Select the member, this member. Then the load is -10 in the middle, so -10. Under load case 2, attributes node force. Select node here on the left, on the right, sorry, and apply. So -30. So we have load case 1, one force in the middle. Load case 2, one force horizontally on the right. Under result, we have linear load case combination. So I will add a new load combination number 1, and we have 1 and 1. Okay. So now everything is ready to run under solver linear static. I will make it example 1, version 2, or part 2. So we have everything is okay. So solve. No errors, so no problems. We have some warnings, but we can ignore the warning. But let's see the answers. So under results, open results file, open. We have one load combination. So now we can show the results. Open results file. The displacement scale, let's say set it as 10. So this is the load deformation, the load like the deformed shape. I will just edit this one. View from infinity display, make it line again. So this is the load deformation from the load case 1. This is from load case 2. And this is from the load combination. Okay. To show the results, we have result settings, diagram. Let's see if we show the shear force here, apply. Apply. Can you see any shear force? So again, results, I will make it 0 again. So is there any shear force here? Again, results, shear force, bending moment. Why there is no shear force or bending moment? Do you have any idea? If we show the axial loads, Okay, now we have the axial load. If we want to show it as contour, so under also there is draw as, we can show as contour. What is the forces here? Force. So we can show the axial load here. This is the axial load. If we make it view infinity display, solid again. So this is the axial loads. I have a question to you again. What is the, why we can't see the moment or shear? Why the moment and shear on this are 0 and in the previous example it was not 0? Because again, the second part of the example is truss, and the trusses can only carry axial loads because the connection is bent, so there is no shear or bending moment. But for the first part of the example, we model it as a frame, so the frame has moment and shear and the axial load. Okay, this is the main difference between the truss and the frame. Okay, if you want to show again the views, the 3 views, to make it easier for you, again under view there is option of multi-view. You can select view 1, 2, 3. Okay, so first view is look is 1. Okay, so this is load case 1 on the left, load case 2 in the middle, load case 3 on the right. Okay, how, what is the values? The values is given here on the side of the contour. So this is the maximum case because this is a summation. So here, if you can see, the maximum positive force is 35 kilonewton. The maximum negative force is only negative 7.07. Okay, where is the maximum positive force? The maximum positive force on the bottom chord, which is beam number 1. How to show the number of members? This is a good point as well. Under view, here is attribute, sorry, intensity display, sorry. So we have here the numbering. If you want to show the numbering of beam, so this beam element under numbering, so you can show the beam numbers under numberings, beam numbers. So apply. Now you can see, if you have a look here, this is member number 1, member 2, member 3. So the maximum force is at member number 1. The maximum negative force is member number 6. Which member number 6? This one, the inclined member here. Okay. Do you have any question for this one? All good? So now stop sharing this one and we'll share screen 3. Yeah. This is the example number 1. Now we have example number 2. This is the example number 2. This is a frame as well. This is a frame with some wind load from wind load calculation, and we don't care about what is the load coming, where is the load coming from, because we are only modeling what we have now. So we have frame and we have uniform distributed load on the columns and uniform distributed load on the beams. Okay. So now I will start doing this example. And as you can see here, also we need to set the dimension, the coordinates, to make it easier for us to draw it. So if this our frame, we have a hinge here and a hinge here. So we have two hinge. This is 10 meter. The height of the column is 2.4 meter. The total height of the crest is 4 meter. The applied load, we have applied load here. On this side, what we have, how much is the load we have? 25 kilonewton per meter. All the loads are 25 kilonewton per meter. Here, how much is the load? Also 25 kilonewton per meter. Here is 25 kilonewton per meter. Here is 25 kilonewton per meter. Okay. What is the beams? What is the definition of the properties? Not all the members are same. As you can see, the columns are UC, universal column. The beams are universal beams. So this member is 250 UC 89.5. The beams are, so this is the two columns. These two beams are 250 UB 37.3. Okay. So this is the members. Now to make it easier for us to draw, what we need to do, we will assume that we have the origin. What is the point of origin we can set? This will be our origin. So this will be our y-axis. This will be our x-axis. So we have node 1. What is the coordinates of node 1? 0 and 0. Let's say this node 2. What is the coordinates of node 2? 10 and 0. This is node 3. What is the coordinates of node 3? 4 or 2.4. Sorry, not in x. It is 0 in x and 2.4 in y. This point, point number 4 is this in the middle. So 5 meter and 5 meter. So this will be 5 in x and 4 in y. This will be 10 in x and 2.4 in y. Point number 5. So we have 5 nodes to draw the frame. So now we'll go to the software. We'll open a new file. What is the units we have? Meter, MBA, kilonewton, Celsius, and that's it. Now we will start again, create node. Node number 1 is 0. Node number 2 was 10 in x, 0 in y. Node number 3 was 0 in x, 2.4 in y. Node number 4 was 5 in x, 4 in y. Node number 5, the last node was 10 in x and 4 in y. Apply. Sorry, the last node is not correct, so we'll need to delete this one. So create the node number 5 is 10 in x, 2.4 in y. That's it. So if we, this is to zoom out, and now we can see the 5 nodes we have. So I will create the members by connecting these nodes together. So this is a beam element, so beam 2. So I will connect node number 1 and here, and here, and here. So this is the frame we have. And the second step after we draw the elements is to assign the supports. So the supports under attributes, node, restraint, and this is hinge. So prevent X, allow rotation in Z. And also the good thing is the two are hinged, so we can select both together. And can you see that when we select the node, it is purple. So apply. So now both of the supports are hinged. What is the next step after we assign the supports? The next step is to define the material. So under property, beam, how many elements type we have? 2. But in our drawing, we only draw is 1. So this was a problem. So what we need to do is select these two member and delete them because we need to draw them with a different coordinate, with a different probability. So now the columns are probability number 1. So we need to create node again in the middle, which was 5 and 4, just to make it easier for us. So to make it easier from the start, when we create element for the beams, we have to select property number 2 so that the software will understand that we have two material properties. So now from this node to this node, we connect using a different property. So this also different property, because we know if we go back to the original problem. So the original problem, we have two types of sections, so we cannot draw them with same property. Okay, so now we go back. Okay, so now we can go to property, beam. When we define, we have to edit the name. Beam property number 1 was for column. So column is property number 1. Okay, it is a beam or truss, it is a beam. What is the material? We can select the material, it is steel. Okay, if you want to change the color, if you don't like the color, so you can change it from here. Let's say make it this color. What else? From geometry, we go to the library. The column was 250 UC, so not universal beam. We are in universal column. So under universal column, it is UC 250 89.5. So this one, select, give it time to load. So this is the column, and then close. What is next? The material property number 2. So under number 2, beam. So we have beam number property number 2. We will rename it and make it for beams or rafters. So okay, the color will be, let's say, green, and under the material is also steel. So we can now go to geometry library, not universal column, it is a universal beam. So universal beam, the section given as 250 37.3. So this one, okay, give it time to load, and that's it. So close. So now we have assigned the material. If we want to check under view, attribute display. So now the colors have been changed, solid. So now this is our frame. So we have a frame. The columns are different section from the beams. So we have two type of section. The next step is to apply the loads. How many loads we have? How many loads we have? Loads on the columns and loads on the beams. All of them are one load case, so we don't have the load case problem in this example. So just what we need to do is assign the load. So from attributes, beams, distributed force, force global. Okay, so there is something we need to explain here. If you can see this principal plans of the beam elements. So this is because we have two coordinate system, as you can see from in the software, we have global and principal. What is the difference between global and principal? So I will explain on the whiteboard here. Okay, so we have global coordinates and principal or local coordinates. Okay, the global coordinates are fixed, so they cannot be changed, whatever the orientation of the beam element. So this is X, Y, and Z. So whatever the beam, if it is horizontal, vertical, or even inclined, so this will be X-axis, Y-axis. This is X-axis, Y-axis. This is X-axis, Y-axis. So X-axis and Y-axis are always X is horizontal, Y is vertical, and that's it. For principal or local, they are changed with the beam element. Okay, so if this our beam element, so this is X-axis or X-plan, and this is Y-plan. So if this horizontal, so I will make it X dash and Y dash. If it is vertical, so this will be X dash, Y dash. If it is inclined, so this is X dash and Y dash. Okay, so this is local, the difference between local and the global axis or principal and the global axis. Okay, so this means that the principal axis means X in the direction of the element, and X dash is the axis in the direction of the element. Just a second. So X dash is the direction of the element. Y dash is the perpendicular on the element. So this is our principal axis. Okay. But the global axis all the time, X is horizontal, Y is vertical. So if we can go back to our example. So here we have no problem with the vertical member because now if we go back again to assign the loads, attributes, beam, point load or distributed load, distributed load. So we can select force global here. Okay, if we select force global, we can select the two members because they have same forces, or we can select member by member. For this member here, this member, this column, what is the direction of the force? X direction or Y direction or Z direction? X direction. So in global, this force in X. How much the force is? It is 25 kilonewton per meter. It is it to the right or to the left? To the right. So it is positive. Okay. Do we have any distance from the start to the start of the load? No, so A and B are 0. Okay, so now apply. So now we have a force acting like this. If we want to show the value under view, attribute display, member, this is what is the type of forces here? It is not a force load, it is a distributed force here. So show value, apply. Okay, so now you can see the force. If we want to make it easier for us to see, so make it line. So now what is the force in this column? 25 kilonewton meter, so it's correct. Now, if we go to the next column, zoom out here, zoom in here. So this is the column to the right. Similarly, we can go attributes, beam, point or distributed force, global, same thing because the force in X. So I will select the member and the force is 25 and apply. So now if we look on the frame, we don't have any problem. We don't have any problem with the force on the vertical columns. The problem will be on the columns on the inclined beams. So what we need to do, attributes, beam, distributed force. But here we cannot choose global, we have to choose force principal. Okay, if we choose force principal, we have this. Okay, here what do we have? Direction 1, 2, 3. What is direction 1 and what is direction 2? What is direction 3? If we go back to the, just go back here to the whiteboard. What we had here? So we had x-axis will be number 1 on the software. Y dash will be number 2 on the software. If we need Z dash, it will be number 3. So in principal coordinates or principal local coordinates, we have 1, 2, 3. In the global coordinate on the software, we have X, Y, Z. Okay. So now in the software, here, what we need to select here? Direction 1 or 2 or 3. This force perpendicular to the member, so it is direction